Hey folks, this is Building with Buchanan. Today I'm going to be showing you how to actually take your parts that you've designed in Fusion 360 and slice them to make them ready for the 3D printer. So I'm going to be using my little test part here named Smiley, and I'm going to be using a slicing program called Tinkerine Suite 2, which we use on our Tinkerine 3D printers. We use a different program called Cura for the other 3D printers. I'm going to save that for another video. This one's just going to be about using Tinkerine. So my little test part here, Smiley, has been made in such a way that there's only one body. So every little piece that I've removed from it uh, is not actually making a new body. This is just one solid body, and this is the easiest way to 3D print any part. So if I just right click on body 1 right here, about halfway down the menu that pops up is a little thing that says Save as STL. So STL is a file type. It's a fairly old file type, and really it's just like a basic shape. There isn't a whole lot of extra information that comes with this file type. It's just a basic set of coordinates that says this is how big the shape is. And these are the usual file types that people use when transferring files back and forth to be 3D printed. So if you were to download a certain file from the internet to be 3D printed, odds are it would come as an STL type of file. So just hit OK to all of these default settings here, and it's going to ask you to save it somewhere. So it's asking you to save it somewhere locally, either like say to your documents or somewhere else. Where I'm going to be saving this is into the school share file, onto the Makerspace drive, into the 3D printing files Dropbox, because the way that we're actually going to get this information to the 3D printers is through an SD card. And so if we send this file over to the one specific computer where we transfer files on the SD card, then we don't need to log in and log out on that computer. So instead of saving this as body1, I want to save this as, say, smiley.stl. You don't need to write .stl. It will automatically do that, and just hit save. So then next up, I'm going to open up Tinkerine Suite. So this is what's called a slicing program. Uh, the basics of it is that you put a part in, which is a solid part that you've designed or you've uploaded from or downloaded from somewhere, and then this program slices it into the layers that the 3D printer is actually going to be printing out. So let's start by importing our shape, and because I last printed something from this 3D printing files Dropbox, there's Smiley. If I sort by date modified, Smiley comes up at the top, so there it comes. So Smiley is on its edge, which is going to be a little bit of an issue because the 3D printer works layer by layer. So at layer 0, what it's actually going to be printing is like pretty much nothing, this really, really thin line here. And then the next layers on top of that that it's going to want to try to print are not going to be sitting on the bed. And this is going to be an issue because we need to print on top of either other material or directly onto the bed, or we're going to need to generate some support for it. So that's what these yellow lines, or what the yellow color here means, is the material isn't supported underneath it, and the program's going to have to build support if you want to print it this way. So what I'm going to do, instead of printing it this way with a bunch of support, I'm going to rotate the whole part around and try to print it like this. Now, you might have noticed that when I changed the angle, I didn't quite get 90 degrees. I got like 92 or so. So let's see what happens underneath. We still have that yellow color everywhere, and if you kind of go off to the side on the side view, you can see I'm not totally laying flat on the machine bed. So this is almost guaranteed to result in a failed print because you're going to print this first layer here, and then the layers over here are just going to be printed on thin air, and so they aren't going to go anywhere. It's just going to make a little pile of 3D print spaghetti, and your print's probably going to fail. So I'm going to hit this button here, lay flat, which then pushes the shape down, and whatever the biggest surface is, this program usually makes it lay flat on that biggest surface so that we have the best chance of actually sticking to the bed. Because the second way that prints usually fail is that they don't stick properly to the machine bed. The extruder comes back and forth and it starts knocking your part, and the part moves with the extruder, kind of like this, which then you're not actually printing where it's supposed to, and you just end up with a big pile of goop. So while I'm moving this around, I'm going to move it over to the corner here because like I said, the second way that prints can fail is that they don't stick to the bed. So just imagine if everybody prints the same thing right in the middle of the bed right there, all of a sudden the stickiness, the little bit of glue that we add to the printing bed, gets worn out pretty quick. So if you move your part over to one of the four corners, there's a very good chance that that's not going to happen. So let's zoom in a little bit and start going through some of the settings that we're going to use. The resolution just means how much material are you going to extrude per layer. So for a simple part like Smiley, there's no reason why I shouldn't use a low resolution. 0.3 millimeters per layer is still very thin. If you want to go up to an ultra high resolution, that's 0.05 millimeters per layer. That means that the machine needs to move 6 times as much just to build up the same amount of material that you would on the low setting. That means it's going to take 6 times as long. So when we only have a few 3D printers in the room, this is going to be an issue in a classroom. So I'm going to stick to low resolution unless in some kind of weird extreme circumstance I need to make a really precise part, in which case I might go to medium or in really odd cases to high, but I never actually use the ultra setting. The next one is the infill. So what this is asking for is, on the inside of our part here, how much do we actually want to fill in outside of the walls? So with Smiley, because I've actually hollowed out the shape, there's only a 1 millimeter thick wall everywhere. So the density that I use for this shape is not particularly important. The only thing that you need to sort of remember for the density is a completely hollow inside may not be strong enough. If you're only printing, say, 2 walls thick, then it might be a kind of a fragile shape. If you go with a dense infill, then you're wasting a whole lot of material that you don't need, because actually a fairly hollow shape works out better because it warps less and you use less material. So I'm going to go for just a sparse. Now you'll see that when I click on sparse, it defaults to 18% infill, which I think is a little bit too much. So I'm going to go into the advanced settings here and open up the debug settings. And this is where we have access to a whole lot more of the settings that we can change to make our prints work better. The travel speed and perimeter speed, you shouldn't touch those. Those are kind of set by the machine. A skirt and a brim are two things that are probably going to affect whether your print works or it doesn't. Basically, these just make a little layer around the outside of your part, like it's adding material to help your part stick to the machine bed. A skirt doesn't actually touch your part, it's just to kind of lay a baseline. A brim actually adds a few layers to the base of your part. I'm turning the brim off because I think I have enough surface area touching the bed that I don't need it. The reason why I'm in here is I want to change my infill percent down to about 12% or so. The one other thing which we commonly change in this debug setting here is the support infill. So there's a difference between infill and support infill. The infill is like the space in between the walls. So like if I were to zoom way in, the infill would be like the space between this layer and this layer. The support infill is what happens when we need to build up just a little bit of support in order to print something higher than it. So in the case of Smiley here, when I slice it, you'll see because it's hollow on the inside, we need to build up some support on the inside. And if that support density is too high, you have trouble actually removing that material afterwards. So I stick to about 10% for the support infill. Let's hit save and close to get out of there. Our wall thickness, I usually do 2 walls thick. This just means that you're printing 2 layers of plastic around the outsides. The support that we're going to generate, for this one we are going to need support. So I'm going to go for full support on this. The filament size doesn't change. We only use 1.75 millimeters. The printing speed really shouldn't be adjusted much more than 80 millimeters a second. That's already pretty quick. And the temperature that the extruder works at, 220, seems to work well for the Tinkerines. All of these settings can be adjusted, and as you get a little more experience with 3D printers, you're going to want to play with these settings a little bit to try to get what you want. I'm just going to hit slice right now and see what happens. So one nice part of the Tinkerine software and all the slicing softwares is that it gives you like a live model of what's going to happen layer by layer. So at layer 1, here's what's going to happen. There's my 2 walls thick in green. The blue is the infill that we're making in order to support the top part of this part. As I go up in layers, the support actually thins out a little bit. We're going to go up, up, up. So we're just printing a few walls right now. And up a little higher. There we go. So if it wasn't for this support, I would be trying to print the bottom of the eyes and the mouth of Smiley here on top of thin air, and that wouldn't work. So these little blue lines have actually generated just a little bit of print material that we're going to break away at the end. And then there's the end. So this should take somewhere along the lines of 4 minutes. Realistically, it takes the machine about 4 or 5 minutes to heat up, so this is probably about a 10-minute print. It says it uses 1 gram. It's probably somewhere around there. So I'm just going to hit save for print. And if I had an SD card hooked up to the computer here, I would just save it right onto the SD card. I'll save it to the computer right now and then transfer it to an SD card later. Yes. So that's basically it. That's slicing apart and learning how to change the settings a little bit to make it work for your specific part. This is for the Tinkerine software specifically. For using the other 3D printers in the room, we're going to use Cura. But basically that's it. Once your whole part is sliced and you've saved it onto your SD card, it's just a matter of taking it over to the printer and basically hitting print. So that's it for now. I will see you next time.